I have introduced you with the two types of reference frame in the first lecture. The first one was inertial frame and the another was non-inertial frame. And you have learned that actually in inertial frame Newton's laws of motion are valid, and so it is possible directly to write the equation of motion, that is the second law of motion, that is F equal to ma in an inertial frame. But if you wish to write this equation of motion in a non-inertial frame, is it possible? Answer is no. We cannot write equation of motion, or we cannot apply Newton's second law of motion directly in a non-inertial frame, because in a non-inertial frame, you know, Newton's laws of motion are not valid. But how we can actually write this equation of motion in a non-inertial frame? Actually, this can be written, but after some extra thinking. Actually, a great mathematician, de-Alembert, has devised a technique how to write equation of motion in a non-inertial frame. In fact, when we want to write equation of motion in a non-inertial frame, we have to think about an imaginary force, which is not actually a force but a force-like term, which is called pseudo force or fictitious force. And taking this pseudo force or fictitious force under account, one can be able to write down the equation of motion in a non-inertial frame. So how it is possible to write equation of motion in a non-inertial frame devised by de-Alembert, we will learn in this lecture. And for this you can see this figure. I have considered here actually two frames of reference. First one is S. It is a stationary inertial frame. Mark this. What is this S? S is an inertial frame. S is an inertial frame. Okay. And this S prime which you are looking in this figure, this S prime is actually a non-inertial frame. Non-inertial frame. And you know, if S prime is a non-inertial frame, definitely S prime will be in an accelerated motion with respect to this inertial frame S. Now let us consider there is a particle in motion and mass of the particle is m. I have shown this trajectory along which our particle is moving, and during the course of motion we consider that at any moment t the particle is at this point P. Okay. And I have shown the position of this frame S prime also here at time t. It means you can imagine that initially S prime was coinciding with S, and as S prime is moving, so after a time t, the frame S prime has reached to the position which you are seeing in this figure. Okay. Now I have actually specified some specifications here. You can see, if you will join the origin O of coordinate system S or frame S to the position of the particle, then this line OP represents the position vector of the particle at time t, and the position coordinate of this point P in frame S I have marked here by X, Y, Z. Okay. And similarly, this R prime represents the position vector of the same particle with respect to the origin of the frame S prime, which is a non-inertial frame. Okay. So O dash P, this is equal to R prime. And I have also shown in this figure that at this time t, the position vector of the origin of non-inertial frame O dash is with respect to the origin O of the inertial frame S is R naught. Okay, so OO dashed, which is position vector of origin of S dashed with respect to origin of S, is R naught. Position vector of the particle with respect to the origin of the frame S dashed is R dashed, and that of with respect to the origin of the frame S, it is R. Okay. Now actually our aim is to write down the equation of motion of this particle in motion in non-inertial frame. Okay. So definitely for writing the equation of motion, first of all we will have to find the acceleration of the particle relative to that frame. And for getting the value of acceleration, we have to relate these position vectors at first, and after that we will relate the velocity of the particle in two frames, and then we can relate the acceleration of the particle in two frames. So this is the plan how we will actually proceed. Okay. And now you can see this vector triangle OO prime P. You know from triangle of addition that this OO prime plus O prime P will be equal to OP. This is just evident from the triangle of addition. Okay. And so you can write here, I have actually marked all these things here, you can see from this triangle of vector addition we have written here OO prime plus O prime P is equal to OP, but OO prime is R naught, O prime P is R dashed, and OP is R. And so you can write the expression for R prime, which is position vector of the particle with respect to the non-inertial frame at time t. This R prime will be what? This will be simply R minus R naught. You can see R prime is R minus R naught. So this is the relation between all these three position vectors. Now our aim is to relate the velocity of the particle in two frames, and for this you know velocity vector is simply the time derivative of position vector. So if your aim is to relate the velocity of particle in two frames, you must differentiate this equation 1 with respect to time t. So I have differentiated it with respect to time t. You can see this is dr prime by dt equal to dr by dt minus dr naught by dt. And this dr prime by dt, I have written it v dashed, dr by dt has been written by v, and dr naught by dt by v naught. Now let us see what is this v. V, this is velocity of our particle at time t. So I have written it here v of t. It means this velocity is time dependent, or this velocity is at time t, and this equals to dr by dt. Since r is the position vector of the particle with respect to inertial frame, so this dr by dt will give velocity of the particle with respect to the inertial frame S. You can see here. Similarly, since r dashed is the position vector of the particle with respect to the non-inertial frame, so this derivative dr prime by dt, this will give the velocity of the particle in non-inertial frame, with respect to non-inertial frame, that is v dashed. Okay. And you know that this r naught, what is this r naught? R naught, you know, this is position vector of the origin of the non-inertial frame with respect to the inertial frame. So when you will differentiate r naught with respect to t, you will get the velocity of non-inertial frame with respect to the inertial frame. So v naught is velocity, v naught is not the velocity of particle, it is velocity of the non-inertial frame, mark it, with respect to the inertial frame. Okay. So in this way we have related all these three velocities. Two velocities are of particle, and this v naught is velocity of the non-inertial frame. But our final aim is what? Our final aim is to relate the acceleration of the particle in two frames. Okay, and for this, time derivative of velocity, that is dv by dt, that is the value of acceleration. So if your aim is to relate the acceleration of the particle in two frames, you must differentiate this equation 2 with respect to time t. So now let us differentiate equation 2 with respect to time t. So see this equation and differentiate it. This will be dv prime by dt equal to dv by dt minus dv naught by dt. And dv prime by dt, I have written it a prime, dv by dt, it has been written by a, and dv naught by dt has been written by a naught. Now let us see what is this a. A is the time derivative of v, and v is the velocity of the particle with respect to the inertial frame. So this time derivative will give the acceleration of the particle with respect to inertial frame. Okay. Similarly, since v dashed is the velocity of the particle with respect to non-inertial frame s dashed, so this derivative will give the acceleration of the particle with respect to the non-inertial frame s dashed. And since v naught, this is velocity of the non-inertial frame with respect to the inertial frame, so this a naught, which is dv naught by dt, that will give acceleration of the non-inertial frame s dashed with respect to the inertial frame s. Okay, and so this equation 3 is actually the relation between the acceleration of the particle a in inertial frame and acceleration of the same particle in a non-inertial frame, which is a dashed, with which is actually moving with acceleration a naught. Okay. Now our aim is actually to write down equation, how to write equation of motion in non-inertial frame. But for convenience, first of all, I am writing here the equation of motion of this particle in the inertial frame, and it is well known to you. It is possible because Newton's laws of motion are valid in an inertial frame, so it is possible to write down its equation of motion in an inertial frame. When you say equation of motion in classical mechanics or in Newtonian mechanics, it means you have to write down the expression for the net force, and according to second law of motion, net force is equal to mass times acceleration. That is called equation of motion. And here a is the acceleration of the particle with respect to the inertial frame. Okay, and m is mass of the particle. So when you will multiply this a by m, you will get the resultant force, total external force or total real forces acting on the particle, and that will be the equation of motion. So you can see, then if F represents the total force, or you can say the resultant of all the actual forces, real forces acting on the particle, then according to Newton's second law of motion, this F will be equal to ma. And this equation F equal to ma is nothing. This is called equation of motion of the particle in an inertial frame. So you can see it is very easy to write down this equation of motion. But now we will see how to write equation of motion in a non-inertial frame. As in a non-inertial frame, Newton's laws of motion are not valid. So if F is the net force, resultant force, as you have assumed, in a non-inertial acting on the particle, and you want to write down the equation of motion in non-inertial frame, and you write that F is equal to m times a dashed, where a dashed is the acceleration of the particle with respect to the non-inertial frame. Is it possible? Is it possible? Answer is no, it is not possible. It will be possible only when A dashed will be equal to A. Only then it will be possible. But let us see, A dashed is not equal to A. A dashed is equal to A minus A naught. So definitely in a non-inertial frame, the resultant of all the real forces F is not equal to mass times acceleration with respect to non-inertial frame. It is not possible because A dashed is not equal to A. So let us think how we can write equation of motion in a non-inertial frame. For writing this equation of motion, you have to simply multiply this equation 3 both sides by mass of the particle, that is by m. So when you will multiply this equation 3 by m in both sides, what will be your result? You can see. Actually, I have written in LHS this factor. M times A minus A naught equal to MA dash. This can be written. Okay. And this will be MA minus MA naught equal to MA dashed. Okay. And MA, you can see equation number 4. This is equal to F, which is actually the resultant of all the actual forces acting on the particle. Whatever force will act on the particle, the resultant is F. And I have written this F naught instead of minus MA naught. Minus MA naught. So F plus F naught, where F naught is equal to minus MA naught, that will be equal to MA dashed. And this is actually the equation of motion in a non-inertial frame. This is equation of motion in a non-inertial frame. This is equation of motion. But let us see, and you can check what is this F naught. Since it is equal to product of mass into some acceleration, so definitely this quantity F will have dimensions of force. But is it a real force? Answer will be no. It is not a real force. Why? Why it is not a real force? You can check it. Actually, if F naught will be a real force, you know, when mass of a particle is multiplied by the acceleration of the same particle. Let us consider that this is a particle and its mass is m, and it is moving with acceleration a. A is the acceleration of this particle. Then ma will give force acting on this particle. But is it possible that we will multiply the mass of the particle by acceleration of some other body? Can that will give the force acting on the particle? No. Then on you, several forces will act always. If I say that I will multiply your mass with the velocity of a car moving on the road, acceleration will be of car and mass will be of yours, and that will be multiplied. That will be a force acting on you? No. Because mass is yours and acceleration is of car. So that product will not give a real force. But dimension will be same because it is product of mass and acceleration. So this F naught is not a real interaction, not a real force. It is not actually acting on that particle. This is just a force-like term, not a force. Such a force is actually called a pseudo force, a fictitious force. It is not a real force. Okay. Actually, I have mentioned it. You can see here. This F naught equal to minus ma naught, and I have written it m times minus a naught. This is actually called the pseudo force. Okay. And I have written here, is F naught a real force? Answer is no, it is not a real force, because m is mass of the particle and a naught is acceleration of the non-inertial, not force but frame, non-inertial frame. So when we multiply mass of a particle with the acceleration of the same particle, then we get force. Here mass is of particle and acceleration is of frame. So this product will not give a real force. It is not a real force, but it is a pseudo force. Okay. And how we can now write the equation of motion in non-inertial frame? You can now easily say, if your aim is to write down the equation of motion in a non-inertial frame, what we will have to do? We will have to add this pseudo force in real force. You have to add pseudo force in real force, and then that will be equal to mass into acceleration with respect to non-inertial frame. This is equation of motion. So in an inertial frame, real force equal to mass of the particle into acceleration of the particle in that frame. But in a non-inertial frame, the equation of motion will be what? That will be real force plus pseudo force, and that will be equal to mass into acceleration of the particle with respect to non-inertial frame. So whenever you have to write down equation of motion in a non-inertial frame, you have to first of all think about the pseudo force. And how that pseudo force will be obtained? We will take mass of the particle and acceleration of the non-inertial frame, and then you have to put this minus sign. It means pseudo force must be acted upon the particle in opposite direction of the acceleration of the frame. It means if your frame is moving, let us say, in positive x direction, and you have to apply a pseudo force on the particle, you must apply that force in negative x direction. It means pseudo force is always in opposite direction of the acceleration of non-inertial frame. If a car is moving in eastward direction and you have to apply a pseudo force on that car, then you must say that the pseudo force will be in westward direction. Okay. So this is the way, this is the technique how we can write down equation of motion in a non-inertial frame. Now actually I am just illustrating this idea by taking an important example, a very simple example. Let us see this figure. Actually this box represents a car, or you can say cart, and this cart is moving with acceleration a0, and there is a simple pendulum suspended from the ceiling of this moving cart. Okay. When this car will accelerate, the string of this simple pendulum will deviate from its equilibrium position. In fact, when the car is not in motion, it is stationary or it moves with constant velocity, then in equilibrium the string will be vertical. But if the car is accelerating, then the string will deviate from this vertical position, and at this position OB, this will be in equilibrium by making an angle theta with this vertical. Now let us calculate what will be this value of theta when the bob of the pendulum is in equilibrium. This is the problem. You have to find the value of this theta made by the string of the pendulum with this vertical in when the bob is in equilibrium. Let us try to solve this problem in both inertial and non-inertial frame. We will try to solve. When you say inertial frame, then you will have to consider an observer, let us say standing on the ground. This observer will see that this car is moving with acceleration a0. Okay, and as the bob is suspended in this car, so this observer will also find that this bob is also moving in this direction with acceleration a0. Its acceleration in this direction will be a0. Okay. When you talk about the solution in an inertial frame, so in an inertial frame, what will be the forces acting on this bob? The first force is mg, okay, which is weight of this bob. The second one is tension of the string, okay, this angle is theta, and with respect to this inertial frame O, only these two forces are acting on the bob: tension of the string and weight of the bob. Okay, and the bob is in equilibrium, making an angle theta with this vertical. Okay, and this observer also finds that the acceleration of this bob is equal to acceleration of the car, and that is equal to a naught in this positive x direction. And we have to find this theta. Now let us see. We can actually divide this t into its component. One component will be along this vertical direction, another component will be in this horizontal direction. As this angle is theta, so this will be also theta, and this component will be t cos theta, and this is t sin theta. I have also shown this fact in this figure, you can see. Okay, now we will write down the equation of motion of this bob in this inertial frame. You know, equation of motion is what? Fx equal to max. It means net force in x direction equal to mass into acceleration in x direction. But what is net force in x direction? See, this is x direction. So net force in x direction is t sin theta. And ax, acceleration in x direction, this is simply a naught. So t sin theta equal to ma naught. Okay. Again, this observer also finds that the bob has no acceleration in this vertical direction, no acceleration. And for vertical direction, we will write equation of motion like this: Fy equal to may. But what is this Fy? Since t cos theta is in upward direction, mg is in downward direction, so this Fy will be equal to t cos theta minus mg, and that will be may, but ay is equal to 0, so this will be 0. So t cos theta minus mg equal to 0, and so t cos theta will be equal to mg. Now since we do not know the tension T and the angle theta, but in this problem we have been asked to calculate theta, so we must eliminate this T, and for eliminating T you can divide this equation 1 by this equation 2. So when T sin theta will be divided by T cos theta, you can see that will be equal to ma naught divided by mg. Here m and m cancel, this t and t cancel, and sin theta by cos theta will be equal to tan theta, and this is a naught by g. Okay. So in this way you can see that in an inertial frame we have solved this problem and calculated the value of theta, which is a naught by g. So you can see that this theta will depend on a naught. So if a naught is 0, let us say, what will be tan theta? Tan theta will be 0, and this implies theta will be 0. It means if the car will move without acceleration, or it will be stationary, then in equilibrium the string of the pendulum will remain vertical, it will not deviate. It will be deviated only when car will accelerate. Okay, but when acceleration is 0, then the string of this pendulum will be vertical and theta will be equal to 0. And if you consider that a naught is increasing and finally it becomes equal to g, a naught is equal to g, then what will be this tan theta? A naught equal to g, this tan theta will be 1, and so theta will be then 45 degree. So when the car will accelerate with an acceleration equal to acceleration due to gravity g, then the deviation will be 45 degree. At an 45 degree angle, the bob will remain in equilibrium. Okay. So this was the solution of this problem in an inertial frame. But the same problem can be also solved in a non-inertial frame. And you can mark it. When we were solving this problem in this inertial frame, we have never talked about any pseudo force. There is no pseudo force acting on this particle. We are only considering the real forces. mg is a real force which is exerted by the earth on the particle. T is the tension of the string, okay, which is a real force. No pseudo force, no imaginary force, no fictitious force has been considered. So there is no need to consider any pseudo force in case of solution of a problem in an inertial frame. But whenever you will try to solve the same problem in a non-inertial frame, you must take into account the pseudo force. Only then you can solve. Let us see how this is possible. So I am here solving the same problem in the frame of the cart. As this cart is moving with a constant acceleration a naught, okay, with a constant acceleration a naught. So this is a non-inertial frame. Now consider that there is an observer standing in this cart. There is an observer, okay, and if this observer will be asked that this bob is either at rest or in motion, what will be his answer? His answer will be the bob is at rest, because with respect to this observer which is already standing in this cart, this bob is not moving, it is at rest. So you can say that with respect to this cart, the bob is stationary and it has no acceleration in any direction. Can you say that in this case there is an acceleration in x direction? No, because the cart is also moving with a naught acceleration and the bob is also moving with a naught acceleration with respect to an inertial frame. So the acceleration of the bob with respect to the cart, that will be a naught minus a naught, that is 0. So in the frame of the cart, the bob is stationary. So there is no acceleration in x direction, ax will be 0, and there is no acceleration in y direction, ay will be also 0. No acceleration in x direction and no acceleration in y direction. In which frame? Let us say, in which frame? In the frame of the cart. There will be no acceleration either in x direction or in y direction. Now, if you want to solve the problem in the frame of this cart, then say me what will be the forces acting on this bob. The first force, you can say this is mg. This is force of gravity. This is a real force. This is real force. Another force which is T, this is also real. These two forces were present also in case of the inertial frame. But as we are not talking about motion of this bob in the non-inertial frame of cart, so we have to think about the pseudo force. You have to think. And you have just learnt that the pseudo force is equal to what? For getting the value of pseudo force, we consider mass of the particle, and acceleration of the frame, and frame's acceleration here is a naught, and then we put actually minus sign. It means this force must be applied in just opposite direction of the acceleration of the frame. Since acceleration of the frame is in positive x direction, so on this bob you have to exert this pseudo force in the negative x direction. So now you can say that in this frame there will be a pseudo force which is ma naught acting on this particle but in negative x direction. I have already shown this force in negative x direction, so I have not written here minus sign. Now again you should divide this t into its component. The vertical component, you can see the figure, since this angle is theta, this will be also theta, so this is t cos theta, and in this horizontal direction or positive x direction its component is t sin theta. Okay, and neither ax is 0 and ay is also 0. So now write the equation of motion of this bob in this non-inertial frame of the cart. You know, first equation will be again fx equal to max. But what is this fx? Since in positive x direction force is t sine theta, in negative x direction force is ma naught, so fx will be t sine theta minus ma naught. But ax is 0 because in the frame of the cart the bob is stationary. Okay, so I have written here 0. So t sine theta equal to ma naught. Okay, and similarly you can see in the vertical direction the net force will be t cos theta minus mg, and there is no acceleration in vertical direction, so this is 0. So t cos theta is mg, and again you will divide that t sine theta by t cos theta, and your result will be tan theta by a naught by g. So you can see this is just another method to solve the problem. The concept of pseudo force is just another method. Okay, we can solve the same problem both in inertial frame and in non-inertial frame, but there are some problems whose solution is very difficult in an inertial frame. So in that situation it is just a compulsion to solve the problem in non-inertial frame. Actually in this chapter later on we will see the solution of the problem in rotatory non-inertial frame, and if anybody will try to solve that problem in an inertial frame, that will be a tedious task. So in such cases we always follow the solution of problems in rotatory non-inertial frame. Okay, so I think after this lecture you have definitely got a concrete basics of the inertial and non-inertial frame, and in the forthcoming lecture we will start our syllabus of motion in a rotatory frame. Thank you very much.